Okay, here we're asked to solve the equation 2x over x minus 4 equals 8 over x minus 4 plus 1. One note before we solve this equation, x can't be 4. Why not? Because 4 minus 4 gives me 0 in the denominator. We can't have 0 in the denominators. So x cannot be 4. So we see that our LCD is the same denominator we have. The common one here is x minus 4. So we multiply everything by x minus 4. And what that does is the x minus 4 above will cancel with the ones below. And then we multiply through. So we simplify this to get 2x, x minus 4's cancel, equals 8, these x minus 4's cancel, plus 1 times x minus 4, or just x minus 4. Take this out of the parentheses and we get 2x equals 8 plus x minus 4. Combine like terms, 8 minus 4 is 4. So we get 2x equals 4 plus x. Subtract x from both sides. In other words, subtract an x here, subtract an x here to get rid of that x on that right side. So we end up with x equals 2x minus x is x equals 4. However, we just saw that x cannot be 4. So our answer is, there is no answer. This is not a solution. So we say no solution to this problem. This problem we're asked to solve for x, 4x divided by x squared plus x minus 30 plus 2 over x minus 5 equals 1 over x plus 6. So again, we have to find our common denominator. We might want to know that x squared plus x minus 30 can be factored into x minus 5 times x plus 6. And so why don't we replace this denominator with its factored form? And now on close examination we see our LCD is actually going to be this denominator, x minus 5 times x plus 6, which contains each of these factors as well. So we multiply both sides of the equation by x minus 5 times x plus 6. And why do we do this? Because we're going to cancel out the denominators. Notice these two cancel out here, leaving with 4x. Here, x minus 5 will cancel out with the one below to leave me with 2 times x plus 6. Here, x plus 6 will cancel out with x plus 6 to leave me with x minus 5 on the top here. So let's rewrite our equation now, what's left. So we have 4x plus 2 times x plus 6 equals x minus 5, 1 times x minus 5. Now we might want to note that as we were doing this, we could have made this restriction here that x cannot be 5 and x cannot be negative 6 as we go along. Why? Because those would make the denominator 0. So you want to make a note of that somewhere on your paper. So now let's continue expanding this. 4x plus 2x plus 12 equals x minus 5. Combine some like terms, 4x plus 2x is 6x. And then move the x's around and the numbers around, so subtract x from both sides and subtract 12 from both sides. So we get 6x minus x is 5x, and negative 5 minus 12 is negative 17. Then divide by 5, so we get x equal to negative 17 over 5. So x is negative 17 over 5. And you might want to check this solution. I'll leave that for you to check. And if you check that, you will find that this is actually the solution to our original equation. What was our original equation before we did all of this? It was 4x divided by x squared plus x minus 30 plus 2 over x minus 5 equals 1 over x plus 6. Now, so you want to check this and make sure that is a solution, works in there. There is another method to solve these types of equations. If there is a solution to an equation with one variable, we can actually solve this on the calculator. And we're going to see how to solve this on the calculator. The idea is to graph each side of this as a function, as a graph, and find the intersection of the graphs. So let's do that for this particular problem. Let's graph the left side and the right side. Okay, let's suppose you want to solve the equation 4x divided by x squared plus x minus 30 plus 2 over x minus 5 equals 1 over x plus 6. So we have to input that into our calculator. First we put the left side. The left side is 4x, so we're going to put parentheses 4x divided by, in parentheses again, this denominator, x squared plus x minus 30. So close the bottom parentheses and then close the top. So that's that first expression. Then we have plus, and parentheses we're going to be 2 divided by parentheses again for the bottom, x minus 5. So the key here is putting your parentheses in properly. So that's the left side. Y, that's y1. y2 we're going to go 1 divided by parentheses x plus 6. So we have the left side in y1, the right side in y2. We need to find the intersection of these two graphs. You have to make sure you typed it in correctly. First I'm going to try my window as zoom 6. That gives me a standard window, and then I'm going to see if there's some kind of intersection. It's hard to tell here on this graph here. So what I'm going to do is go back to my y equals, and on my second function I'm going to highlight the line here, make it darker by hitting enter. So we hit enter. The line on the second function is darker. So I'm going to hit graph again. There's my first function, and the second function is darker. You see all this dark line. So I don't really know if it's intersecting, but it does look like it's doing something around here or the other. So we can actually zoom in to that spot by hitting zoom and then go in and move your cursor. You see this cursor as I move it around here. Move it to where you think it might be, and let's go down there and we hit enter and we zoom in. So there's my function, the first one. There's the second one, and it looks like we do have an intersection here. The dark line is intersecting the light line. How do we find it? Well, we go second trace, and we scroll down to intersect, and really all you have to do now is hit enter 3 times. First curve, I hit enter. Second curve, I hit enter. Guess, I hit enter. It comes up with my solution as x equals negative 3.4 as the solution to this equation, and that actually verifies what we just found algebraically as negative 17/5.